Class number 4, nth roots of a complex number. Example, find z such that z squared equals to I. So by what we did at the end of class number 3, if we have z to the n equals to z0, then we say z equal to z0 to the 1 over n. And absolute value z is z0, absolute value of z0 to the 1 over n, and arg of z was arg of z0 over n, where arg of z0 can be written as big arg, principal argument of z0 plus 2k pi, k in z, right? So here z0 equals to I. So absolute value of z is absolute value of I to the 1 over 2, which is 1. And arg of z is big arg of I, principal argument of I, plus 2k pi all over 2. And what's principal argument of I? Well, I is here, and I need the angle from bigger than minus pi, less than or equal to pi. So for I, this is pi over 2. Principal argument of I is pi over 2. So that over 2 will be pi over 4 plus k pi, k in z. So z equal to I to the half is, in polar representation, it is 1 times cosine pi over 4 plus k pi plus I sine pi over 4 plus k pi, which is same thing as in the exponential form. It is e to the I pi over 4 plus k pi, k in z. So that is I to the half. Okay, well, let's see where these are located. So in the complex plane, real part, imaginary part, its absolute value is 1, right? And when k is 0, so it is on this unit circle, absolute value is 1. And when k is 0, sorry, its argument is pi over 4, and it is measured from the positive real axis, right? So pi over 4 is right there. That's pi over 4. So when k is 0, this is I to the half. And when k is 1, I am adding pi more to pi over 4, so it goes to the opposite. So that is when k is 1, and that's when k is 1. And when k is 2, then I add another pi, then it jumps back to here again. Okay, so it jumps here and there. Everything else is the same. So I get, therefore I can say I to the half is, when k is 0, I get 1 over root 2 over 2 plus I root 2 over 2. And when k is 1, I get minus root 2 over 2 minus root 2 over 2I. So I have two distinct roots. Okay, I have two distinct roots. How do I obtain these roots? From this one root from k equal to 0, we are adding angles, right? So especially when k is 0, we get that k equal, when k is 0, we get it from the principal argument. Therefore, when k is 0, we call that principal root. That is when k equal to 0, because it is related with principal argument. We get that from the principal argument. So it is called principal root. When k is 0, we call that principal root, and notation for principal root is square root I. That square root is denoted for principal root only for complex numbers. Okay, so I to the half is not the same as square root of I for complex numbers. For I to the half, we have sets of sets. We have a set, right? We have two distinct numbers, but square root of I is unique number. That is only when k is 0. So that distinction is very important. So number 2, nth roots of unity. Unity meaning one unit in the complex plane. So this number 1, 0. Nth roots of unity. So how many distinct nth roots does z equals to 1 have? So z0 equals to 1 half. So if z to the n is 1, then what's z? Z is z0 to the 1 over n, where z0, it has absolute value 1, and then e to the I. So instead of cosine and sine, I can write that in terms of polar form, exponential form, right? So what is principal arg of 1, 0? That is principal argument is 0, and then plus 2k pi. K in z. That thing to the 1 over n, right? So what we do is we take nth root of 1 over n, and then we divide this by n. So when we do that, we get this is equal to e to the I 2k pi over n, where k is in z. But how many distinct roots do we get? Well, we get 1 when k is 0, and then k1, k2, k equal to n minus 1. And when k hits n, when k is n, then this whole thing becomes 2 pi, and then we come back to k equals to 0. So k equal to n will be at the same point where k equals to 0. So we get distinct roots for this case only. So there are n distinct roots. So yeah, how many? The answer is n distinct roots. N distinct roots. That's the answer. And the solutions meaning the nth roots, represent the n blank of a regular polygon of blank size inscribed in a blank circle with center at the origin. So if I draw this in the complex plane, nth roots of unity, real, imaginary. Let's draw e to the I 2k pi over n. So it is on the unit circle first of all because its absolute value is 1. And the principal root is when k is 0. When k is 0, it is here. And when k is 1, we have to add uh, 2 pi over n. So that's when k is 1. When k is 2, we add 2 times 2 pi over n. That's when k is 2, etc. Right? So we are adding 2 pi over n, 2 pi over n, 2 pi over n. So we are dividing the angle, the whole angle 2 pi into n equal subsectors. So this is one root, and thus the second root, third root, fourth root, etc. So if I continue in this manner, if I join them, I get a polygon, 다각형 이렇게 되는 거죠. Where each sides are the same, so it is regular polygon. Regular polygon. So the solutions represent the n n개의 꼭지점, n vertices of a regular polygon of how many sides? Yes, there are n sides inscribed in a unit circle with center at the origin. So nth roots of unity. Those nth roots represent the n vertices of a regular polygon. So how do we draw 17gon? Well, we plot 17th roots of unity. Then I can draw 17gon. 이게 17각형을 어떻게 그리는가? 1에 복소수 1에 이걸 뭐라고 해야 되지? 17 root, 그러니까 1 over 7, 그러니까 1에 1 over 17th를 그리면 되겠죠. Okay. If we let w equal to cosine 2 pi over n, I sine 2 pi over n, meaning w is, that is when k is 1. Okay. So this is w. Then that will be w squared because we are adding the argument twice. The argument of w was here, and we are adding one more of that, so that will be w squared. Because the length from the origin is 1, the length does not change, and that will become w cubed, w to the fourth, etc. Right? So that's what we are doing. Then w squared, w cubed, dot dot dot, up to which w? Because there are n distinct roots, this will be w to the n, which is 1, right? Since there are n distinct roots, if this is w, then if I go around each vertices, this will be w to the n, which is 1. Then w squared, w to the n are distinct, and roots of unity, and w to the n is 1. That's what we notice. Now the product of any two roots of unity is, so if I do Wm times Wl, then what do we get? Well, that is absolute value. How do we multiply Z1, Z2? Yep. So we multiply Z1, the magnitudes of each, and then arg, we add them up, right? That's arg Z1, arg Z2. So it is absolute value Wm, absolute value Wl, and then it is e to the I. See, for W, that is obtained when k is 1, right? So for a w to the m and w to the l, we will have e to the I to m pi over n plus 2 l pi over n. Well, each of these has length 1 there on the unit circle, and if I add these two, it becomes 2m plus l pi over n, where m plus m are again some k. Therefore, this is also a root of unity. So the product of any two roots of unity is again a root of unity. So is, I'm out of space, so let me write the answer here. The product of any two roots of unity is a root of unity. The sum of all the nth roots of unity. When we say all the nth roots here, we mean distinct nth roots, because we started, our context is under distinct nth roots. Okay, so when we add all the distinct nth roots, what is it? That's the question. So we are adding w plus w squared plus dot 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 w to the n. Well, w to the n, remember, that's equals to 1, so this is equal to 1 plus w dot 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 plus w to the n minus 1, right? Which is equal to, what is this? It is 1 minus w to the n over 1 minus w. This holds for complex numbers, because if I set the partial sum as 1 plus z plus dot 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 z to the n minus 1, then z times s sub n is z plus dot 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 plus z to the n. So if we do 1 minus z times Sn, so we're subtracting the second from the first, then we will get 1 minus z to the n. So if z is not equal to 1, then Sn is 1 minus z to the n over 1 minus z, right? So we can write that like this because we know that w is not equal to 1. W was when k is 1, right? So see, w is right there. This is w. So it is not equal to 1. So that's what we have. So that equals to this. But remember, what was w to the n? Well, w to the n was 1, right? That was 1. So what do we get? We get 0. So the sum of all the nth roots of unity is 0. Is 0. None. Pretty interesting.